See here, in the case of DDA algorithm, you start from a point, okay, you move in the x direction and calculate the pixel in the y direction, okay. You move in the x direction and calculate which pixel should be in the y direction. That means if I will come to the next pixel, that means if I am moving to the x direction, so first of all I have to take the middle point. So I have traveled in the x direction by 1 pixel. So on the basis of this travel, there can be three options. There can be two options. One is that y has not changed, that means y is same as the initial y, okay. And in the another case, y has changed by 1 pixel, okay. Y has changed by 1 pixel, that means either this pixel should be into consideration or this pixel should be, okay. So if you have traveled this one, then either this pixel or this pixel should be chosen. So on the basis of the formula of line y equal to mx plus c, okay, what was the formula? Y equal to delta y upon delta x, okay. This was the formula, and on the basis of this formula we have devised the formula, okay. It was actually y minus y1 equal to delta y x minus x1. On the basis of this formula, we will decide whether this pixel or this pixel should be in the on state, okay. The idea of Bresenhams was a little different from this one. This was the initial pixel, and from this initial pixel you have to either choose this pixel or you have to choose this pixel. That means if suppose my line is like this, okay, and I am making the structure of pixel like this, this is our actual pixel structure, okay. Then see here, in this case this was the next pixel, okay, and this was the lower side pixel, and the actual line is passing from this point. It is neither exactly overlapping this pixel or this pixel, but it is actually going to a point which is in between this y plus 1 pixel and y pixel. If I am giving the name of this pixel is xk yk, then the name of this pixel would be xk plus 1 and yk, because xk value has been changed by 1 pixel, and the coordinate of this pixel would be xk plus 1 and yk plus 1, because in the y direction also we have traveled 1 pixel. I am saying that the actual coordinate, this one is xy, this is xy. So what will be the difference between this and this? I am zooming this thing. Suppose this is my line, this is the point which is xy, this is the upper pixel point, this one, and its value is xk plus 1, y k plus 1. So I am taking only y value, that means suppose the height of this pixel is yk plus 1, and for the lower pixel suppose the height is yk only, okay, and in this case the height is y only. So the distance between this pixel will be yk plus 1 minus y, and distance between this pixel would be y minus yk, isn't it? So if we can measure which distance is lower than the other, we will make that pixel in the on state. if this distance is lower than this distance, we make the upper side pixel as the on state, and if this distance is lower, then we make this pixel in the on state. So, on the basis of this decision, the Bresenhams given an idea of decision value. So, he has introduced a variable decision as p, and on the basis of that decision, he has devised a formula. So, this distance is d1 and this distance is actually d2. Okay. So, if d1 is less than d2, we will on the lower pixel, else if d2 is greater than d1, in that case we will on the upper pixel. This pixel is the upper pixel and this pixel is the lower pixel. Now, we are going to the mathematics of this thing. Okay. What is the what is yk, what is y? Let us go to the mathematical detail for this one. See here, there are the equation of line as y equal to mx plus c. The other is yk point and the other point is yk plus 1 point. Okay. We are having the three things. Here in the first case we have to calculate d1. d1 was y minus yk. In the same equation we have to put x as xk plus 1 and we will calculate what the value of y would be. So, if x become xk plus 1, in that case y will be either yk plus 1 or yk. Okay. This was the mistake I have made earlier. So, here when x was moving toward xk plus 1, then y will be either yk plus 1 or yk. So, here in the place of y we can write in the second case, because d1 is for second case. So, I can write here as yk. So, my equation will be y equal to mx. So, because x is moving, therefore, x plus 1 and the constant is c here, and I will write yk as it is. Okay. This was the mistake. I will write y as it is. So, this was my first equation. It is very simple. It is equation number 4, I think. It is equation number 4. In the same way, I can calculate the value of d2. What was the d2? d2 was yk plus 1, yk plus 1 minus y. So, yk plus 1 minus y, this was my second thing. So, here what will be the value of yk plus 1? The value of yk plus 1 we can calculate in the similar manner. It will be m xk plus 1 plus c. I am doing the same kind of mistake again and again. We have to write the equation in place of y, not yk plus 1. I have to write equation in the place of y, not yk plus 1. I have done the same mistake earlier also. So, yk plus 1 minus y. So, in the place of y, I am writing as m xk plus 1 plus c. Okay. Now, I am expanding this one, because here yk plus 1 is actually yk plus 1. Therefore, I can write the equation yk plus 1 as yk plus 1. I will write this thing later stage. So, now what should be our next step? I have to identify whether the value of d1 is larger or the value of d2 is larger. Okay, so d1, so I have to take difference of d1 and d2. So if the value is positive, that means d1 is larger, and if the value is negative, the d2 will be larger, and therefore I have to calculate d1 minus d2. So if I am making this, then m x plus 1 plus c minus yk, I have to write this thing. So m xk plus 1 plus c minus yk, and in the minus side I have to write this one yk plus 1, this minus become plus, and this will be m xk plus 1 plus c in the bracket. So these two things are same because they are same term, therefore I will make it twice. 2m xk plus 1 plus 2c, and here what should I write? What the other terms are here? It is yk minus yk plus 1. Okay, so I have written these two terms here. Now in the place of m, what will be the m? The value of m equal to delta y upon delta x. Okay, delta y means the difference between the initial point and last point. Okay, if this is the line, this was the initial point, and this is the last point. So the difference between the initial point and the last point is actually in the y direction it is delta y, and in the x direction it is delta x. So in this way we can calculate the distance between these 2 points. Okay, so let us calculate this thing. So what will be in the place of m, we can write this thing. So 2 delta y upon delta x, and this equation become xk plus 1 plus 2c minus yk plus 1. Okay, yk plus 1 is actually yk plus 1, and here also yk will become as 2yk. Okay, so when we calculate, we will get the value as, I am writing directly the final value. I have already calculated as, it will become as 2 delta y xk minus 2 delta x yk plus 2 times delta y plus 2 times delta x multiplied by, here I have taken as c, this is c minus delta x. Okay, and now this is a constant because delta y is actually the distance between last point and the initial point in the y direction, and delta x is the distance between last point and the initial point in the x direction. Okay, so actually this will become a constant, and therefore this is constant, because a constant multiplied by a constant will again be constant, and delta x is again a constant. So all this thing will be a bigger constant. So say it will be a big C, and the rest thing will be same, xk minus 2 delta x yk. So in this way we have got an equation like this. Okay, Mr. Bresenhams has said this is the decision parameter because it will decide which pixel should be in the on state in the y direction. So he has said that this is the decision parameter and will be represented by the factor p. So p become 2 delta y xk minus 2 delta x yk plus c. It is very important equation, and on the basis of this important equation Bresenhams has devised the actual algorithm. Okay. So here the main point is that what is P? P is actually D1 minus D2, and what is D1? What is D2? This is yk plus 1. Suppose this is yk plus 1. This point is actually y, and suppose this point is yk. So this distance was D2 and this distance was D1. It is the lower pixel, it is actual line passing, and it is the upper pixel in the y direction. Okay. So if p value is positive, so if p value is positive, that means distance d1 is larger than distance d2, that means lower pixel should be in the on state. Okay. So yk plus 1 will become as yk. Okay. Because when you increase the value of x, the yk plus 1, that means next stage pixel and the previous stage pixel will be same. That means the structure will be like this. This was the initial pixel, and when you increment in the x direction, the y value would not change. Okay, the y value would not change. This was the case. Clear? And if its value is negative, if the value of p is negative, that means yk plus 1 is actually yk plus 1. That means y will also increase in this case. So what will be the actual value? This was the initial pixel, and because the y has also increased, therefore this pixel will be taken into account. So in this way we can take decision which pixel should be taken into account. The decision value for the initial point was given by the Bresenhams as 2 delta y minus delta x. So in this way he has given the two formula. In first case, the formula was pk plus 1 equal to pk plus 2 delta y. Okay. If pk is less than 0, and when pk is greater than 0, in that case pk plus 1 equal to pk plus 2 delta y minus 2 delta x if pk is greater than 0. There are two conditions. Okay. So on the basis of these conditions, I am going to write the algorithm. If I write the algorithm, then in that case the first point is same as the DDA algorithm. That means first of all I have to give the initial pixel and the last pixel. Okay. So input the two endpoint, input two endpoints. Okay. First of all I have to give the input of these 2 points. That means in the question you have given the two endpoint as this point and this point. So you have to give the input just like in the DDA algorithm case. Now we will load the starting point because we have to start from the starting point. Therefore first of all this starting point, I am saying this point as x0 and y0, and I have to load this into frame buffer. Yesterday I have discussed what is the frame buffer. For any graphical drawing, we will use the memory as frame buffer. Okay. So this point would be shifted into frame buffer. So store x y0 into frame buffer. Third point is we will calculate some of the important values like delta x, delta y. Okay. These points are the important point for calculating this formula. Therefore we have to calculate delta x, delta y, 2 delta y, 2 delta x. Okay. 2 delta y minus 2 delta x, because we are going to use these things. Okay. And in the last because the initial decision parameter p0 is 2 delta y minus delta x, we will also calculate in the third step here. In the fourth step, we will take decision, as which of the pixel in the y direction should be in the on state. So, I will write the algorithm as if pk is less than 0, the formula used will be pk plus 1 equal to pk plus 2 delta y. Otherwise means either p is larger than 0 or greater than 0. pk plus 1 equal to pk plus 2 delta y minus 2 of delta x. So, we will take the decision accordingly. Now, the second last point is we will repeat the above step, repeat until we get the last point, okay? Because we have given the 2 point, one is the starting point, one is the last point. So, by increasing one by one, we will get the last point, okay? And because this point is also given, we will match the incremental value with the last point, and if it matches, that means our work has been done now. So, in a very hurry manner, I will discuss example on the basis of this. And after point been given, one point is suppose 2010 is the start point and 3018 is the last point, okay? These are the 2 points. So, what should we do first? First of all, we have to calculate the value of m, okay? So, value of m will be delta y upon delta x, okay? So, what will be the delta y value? 18 minus 10, this will be delta y. So, 18 minus 10 will be 8. What will be the delta x? The 30 minus 20, that means 10. So, the value of m will be 0.8. And likewise, because in the third step we have to calculate all these things, delta x, the delta x value was calculated here as 10, delta y was 8, okay? And p0 was the decision parameter and its formula was 2 delta y minus delta x, and its value was 16 minus 10, that means 6. Likewise, we will calculate the value of 2 delta y minus 2 delta x, because it will also be used because this value is positive, and for the positive I have said that, see here, if the value is positive, okay, pk is positive, okay. Now, it will not confuse. If pk is positive, in that case we will calculate this thing and add the previous value, okay, add the previous decision parameter. So, in this way the initial parameter, that means starting parameter value is 6. So, we will use that formula. So, what will be the value of 2 delta y minus 2 delta x? 2 delta y is 16 actually, and 2 delta x is 20 here. That means its value is minus 4. So, we will add 6 and minus 4, and it will be the next decision parameter. So, okay. So, I am making a table, and on the basis of that table you would be able to understand the whole thing, how the line drawing algorithm by Bresenhams can be used. So, here I am taking the value of k, k is representing the number of iteration, and we have to calculate our decision parameter in every step. On the basis of that, we will calculate the next point, which have to be in the on state yk plus 1 x state, okay. And because the point are so many, therefore I will use the 2 rows. So, here again k, pk, xk plus 1 and yk plus 1. So, in the starting the value of k was 0, will be 0, and here p0 was calculated as 6, and the initial point, the point given in the question is 20 and 10, okay. So, 20 and 10 is the starting point, and 30, 18 was the last point. So, the starting point would be 20 and 10. So 2010 will be the start point, and because the value of pk is 6, therefore if the value is 6, therefore the pixel in the y direction will be incremented. Therefore with increment of x, that means 21, the y will also be incremented, that means it will become 11, because x is the base value. So in every step its value will be incremented. So I am writing all its value 22, 23, 24 likewise, okay, and 25, 26, 27, 28, 29 and 30, because the value is up to 30, and we will decide what will be the value of y. This is our algorithm. So in the next step, what will be the value of p? The value of p will be this plus p. So 6 minus 4, that means its value will be 2. So if its value will be 2, it is again a positive value, and for the positive value the y will be incremented, that means its value will become as 12. Okay. So if its value become 12, then we have to again recalculate the value of this one, that means minus 4 will be added to the previous value, and the previous value was 2, and minus 4 will be added. So 2 minus 4. So the formula of pk, I am writing it here so that I not scroll again and again. So the value of pk plus 1 equal to pk plus 2 delta y minus 2 delta x for the positive value of pk, and pk plus 1 equal to pk plus 2 delta y for negative value. Okay. So its value is positive now, therefore it has been incremented. Now the initial value was 2, and this value I have already calculated, its value is minus 4. 2 delta y minus 2 delta x was minus 4. So 2 minus 4, 2 and minus 4, because its value is 2, 2 minus 4 is minus 2. Now it is negative, therefore its value will not be incremented, so it will become as same. So 12 will become as same. Okay, it will not be incremented. Now if its value becomes same, then this formula will be applied, that means the previous value will be added only this value. So what will be the value of delta y? I think delta y was 8. Okay, 18 minus 10, that means 8. So 8 multiplied by 2, that means 16. So 16 will be added to minus 2, and its value will become 14. So the next decision parameter will be 14 here. 14 is a positive number, therefore its value will be incremented. So it become as 13. So it become as 13, and because it is positive, so this value will be calculated, and it is minus 4. So minus 4 will be decreased from this, so it will become 10. This is again positive, so value will be incremented as 14. Okay, and because 10 is a positive value, so minus 4 will be negated from this, and therefore its value becomes 6. So again it is a positive value, so its value will be incremented as 15, and its value becomes 6 minus 4, that means its value will become as 2. Again because it is a positive value, it will become as 16, and its value will be recalculated as minus 2. 2 minus 4, that means minus 2. Because it is minus value, therefore the value of y will not be incremented, it will become as 16, that means same value. Again the value will become 2 delta y will be added into this value, so it will become as 14. So 14 is the positive value, therefore it will become as 17, it will become 10, a positive value, therefore it will become as 18. Okay. So you have seen that in the last you get exactly the same point as the last point. Exactly you have got the same point as the last point, that means your calculation and your algorithm is correct. In this way you can apply your Bresenhams algorithm. Okay. Any question